All right, the first day of Unit 8, which is going to be all about exponential and logarithmic functions, is just talking about function inverses. So to talk about inverse functions, first we need to kind of re-highlight what a function is. So it's a relation between a set of inputs and outputs. For example, I give you a really simple function of f of x equals x minus 1. So I put numbers into x, and we call those our inputs. And that gives us a list of outputs. And so the idea of a function is just all of those outputs have this same thing in common with their own inputs. So the function is just what is happening to your inputs to get your outputs. So an inverse function is a function that reverses another function. So the inputs and outputs of a function kind of trade places in the inverse function. The way that we're going to denote inverse functions is with that little exponent of -1. So that just stands for inverse function. So when we think about inverse functions, I want you to think about the words reverses or undoes. We need to think of inverse functions the same way as inverse operations. It's going to either undo what's being done or kind of cancel out what's happening. Over on the side, you just have a graph there. If you see the red function, that's our original function. Then here, the blue graph is what the inverse function looks like. So if you notice, the inputs and outputs kind of just trade places. It's the same shape, but they just kind of go in a different way. So we're just going to do one example together, and I want you to find the inverse of the given functions. We're going to follow a couple of steps here. First off, I don't really like working with f of x, so I'm just going to change it to a y, just because one letter is way easier to keep track of than two. Now, I keep saying that it reverses or it undoes. So what I'm wanting to do is I need to undo everything that's happening to x. I'm going to get rid of all of it. There's a couple different things we could do here to start this. The way I kind of teach this to my Algebra 1 kids, if I'm solving for a variable, I want to box that variable in. Everything outside of that box needs to go to the other side of that line I just drew. The first thing I'm going to get rid of is I'm going to divide by 3. I know this will give me a fraction right away, but it moves that 3 to the other side. So that cancels over there, and I'm just left with x minus 7. Well, the last thing I need to do to get x by itself is to add 7 to both sides. So I'm, again, undoing everything that's being done to x. So the inverse is y divided by 3 plus 7. So the output divided by 3 adds 7. Now, when we use our calculator or when we try to graph these types of lines, we always have to have y equals. So I keep saying we're reversing or our inputs and outputs trade places. That's exactly what we're going to do here. Now that I have everything undone and x is by itself, I'm actually going to just switch x and y. Because now, if I wanted to graph this, I would say this would be x divided by 3 plus 7 equals y. Or y equals x over 3 plus 7. If I wanted to graph this, my slope would be 1/3 and my y-intercept would be 7. So the only thing I still want to change about this is, remember I said we denote inverses with that f with the -1. So I'm just going to put that back in for y. F of x and y, they both mean output. So I can just put them, I can keep putting them in place of each other. So again, I could write x over 3 plus 7 or 1/3 x plus 7. But this function is the inverse of the original function I gave you. So this is your try on your own. So remember, you want to first get everything away from x, solve for x, and then you're going to want to trade your inputs and outputs, need to trade places, and then rewrite it as f to the -1 for that inverse function.